Stream number 79 in this series where I am programming an NES game live on Twitch from scratch. This is an afternoon edition. We are starting here after Christmas. Merry Christmas to those of you who celebrated and hopefully had some good time off. I have some days off here between now and the end of the year, and as I mentioned on a few streams now, I'll be at MagFest coming up next week, so hope to see some of you there. I know that a bunch of people from the homebrew community will be there, as well as, of course, the usual suspects from the YouTube community and game developers and stuff like that. I don't know if you've looked at the people on the lineup. I didn't see a schedule of panels for anything other than music at this point, which is cool. I mean, the music panels look really good, but interested in seeing what other panels they have there with some of the attendees. The composer of the Mega Man 2 soundtrack is going to be there, which is pretty awesome. I'm curious to see what panel he's actually participating in. But anyway, so that'll be next week. I'll be at MagFest, and so as a result, I doubt I'll be streaming programming next week, but I will be trying to do some streams with people that are there, kind of just off the cuff, most likely just using my phone, just to get some people some FaceTime on the stream, because it'll be cool to have the people there in person and on stream. And then what else did I want to get started with? I've changed up the audio. The microphone is in a different position now than where it was previously, so you'll have to let me know if that sounds better or worse. I think it'll be better. It's out of the way compared to where it used to be, but it's also more directly in front of my mouth and my face in a straight line, so the sound will hopefully be improved compared to where we were before. And then, yeah, and then I announced in the last stream that I would be starting a pre-order of the game that gets you access to the source code, read-only access in the GitHub project. That'll be something I'll post about soon. And then Zero Pages Episode 3 about assembly language programming. That's in the works. It has been for a while now, and I'm sorry that that's taken so long, but it's been pretty busy. So I'm hoping to get that out by the end of the year. So Monday is New Year's Eve. Like I said, I doubt there's going to be any stream that night, and then Thursday I'll be at MagFest. Anyway, so let's get back to what we were working on in the last stream, and basically what we were doing was we were changing the way that we were importing sprites to support more complex layouts of sprites. So the idea was we have a sprite that essentially is on a sprite sheet, sort of. I mean, we could go that route, but right now the ship is essentially just the only thing on that sprite sheet right now. What do I want to open this with? I don't even know. I'll just open it with a sprite. So here's the ship, and we had imported it without the proper color usage because we had talked about the fact that we didn't really support multiple palettes per sprite, and that's what we were working on. And so I had put together sort of this write-up of what some of the limitations were. As I was thinking about it in between the last stream and now, I also thought about some other issues that we'll talk about here. But let's get the sprite back into a situation where we actually have all of the colors as they're supposed to be. No. Why aren't you pasting what I want you to paste? As I've mentioned, as I've mentioned, I'm not very good with Sprite. I'm still learning it, so we'll just kind of have to suffer through that. The other thing is, let's fix the palette situation. So, there was... Okay. So that loaded the NES palette, and then let's repaste that. It's not doing a very good job of translating those colors. Let's change the setup to use RGB. And then we'll convert it back to indexed. Okay, so there's the ship. And then well, let's make the background some other color. That will be our 0 color. Okay. And then let's go back to indexed mode. Why are you changing the colors? Just indexed. Merge layers. Why is this being difficult? Palette size 64. So weird. I don't know why it's doing that. Anyway, we can fix it. It's just being annoying. Okay. Is that right now? Basically. Yeah. All right. Sorry about that. So, all right. So the problem we talked about is that this is really, at a minimum, it's 3 sprites. It's this here and then these 2 there. If we turn on the grid, right? And obviously we don't want to split this up between 2 separate sprites. That's wasteful. This will fit into one. But the way we defined our code initially, because we were just trying to get things working, was that we were just taking these 8x8s and making them work in a sort of naive way where we were saying, okay, oh, I see, that's what it was doing. Okay. We were working in a naive way where we were saying, okay, you know, just take whatever is there and turn it into an 8x8 tile and then use that for the sprite. And so what we want to do now is we want to be a little bit smarter, and we talked about how we're going to define this in some We have some JavaScript object notation that we've already built for when we import a PNG. This stuff is new, so ignore that. But these parts are the pre-existing. We load that in, and then we use that to define the binary data that we store for the various sprites we are going to have in the game. And so right now we have our collision points that we can define. We can define if it's animated. We can define the bounding box. If it's this one, the explosion, it has no collision points, but it has a frame size because the PNG is a set of frames that are the actual animation, and we are setting what the frame size is for each frame of the animation of that one large image that we have. So if we grab that here for you to see, just as a reminder. So these are 16 by 16 frames, so we've defined that each frame is 16 by 16, and we just cycle through it because it's animated. At some point, we'll want to do things like have timings per frame, potentially, or at least change the timing so it's not one cycle per frame. But until then, what we have is good. So what I was thinking about is something that we had missed, or I had missed when I was working on this last week. And basically that was that we have a limitation in the way that we are not only loading but planning on defining the data for the sprite, and that will create a problem for when we want to draw it on screen. And so the limitation right now is, as I said, if you have an image that's 16 by 16, we divide it up into 4 8 by 8, and then we store that in a single linear stride that's 16 pixels 16 times, right? It translates to one buffer. The problem with that is we want to do something now where we have the 16 by 16, but it doesn't translate into 4 even tiles. What it actually translates into is this 1, and then these 2, and these are all 8 by 8, even though it doesn't look like it because I'm just really crap at drawing. But these are all 8 by 8, and so what we want to do is we want to say, okay, the first one starts here, and then the second one starts here, and the third one starts there. And then the problem with what we've done is that it doesn't allow us to store the data for this properly, because what it's going to try and do is store this whole thing, and what we really want to do is store that first tile, and then we want to store the next 2 tiles. And we have a couple ways of doing that. We have that we can offset the storage so that we create a new we have a couple ways. We have one where we could create a new long image that consists of 3 tiles, and then we have the data be linear like that. That would certainly work. There's nothing wrong with storing it that way. The other possibility is we store it as individual tiles. So the first 64 bytes of data is this. So just to contrast the difference, so the difference is that the first 64 bytes of data, if we store it just linearly, are going to be, 8 chunks of tile data like this. If we do it linearly, so we'll get two full strides, and then a 2/3 of a stride for the image if we look at 64 bytes this way. If we do it this way, 64 bytes is 1 tile, right, over here. And then the next 64 bytes is the next tile, and so on. And the reason that I like that better is that when we're actually drawing the sprite on screen, we have the first tile that we know is going to live there, and then we have the next tile that is going to live there, and the next tile that's going to live there. So for the asset tool to display it, it's easier, and then for the asset tool to export it to charrom is it's going to be easier too, I think. So we're going to have to change how we're storing that data. It's not that big a deal, but it'll take a little doing here to change that. So let's get started with that process. Let's change how we're storing the tiles first, which it's kind of annoying because if we're just taking a straight up PNG and reading the data out of it, depending on the size, it requires some just annoying math essentially that we're going to have to do. So let's see. So here's load image. So that loads the image memory. And then we're converting it to indexed, and then we're loading the palette. And then, okay, so in the process of creating the sprite, most likely that's where I want to do this conversion from the longer stride of image down to the individual tiles. So what does that mean? So what that means is that here, where we are just writing out the image by width and height, which is one single operation, what we're going to do is we're going to populate memory that's the same size with the tile data, and then we'll write that out individually. And the reason we want to do that, I mean, it's not so important now with SSDs being in play, but ultimately it's just faster to do this, to do one long contiguous disk write. On older spinning disks, obviously, the drive can just write the data out as a contiguous stream of bytes, right? If you're doing it in pieces, you're doing sort of chunks of data over and over again. Again, SSDs make this a little bit less of an issue, but it's still a good thing to do because it's even SSDs, I believe, operate faster on contiguous operations than they do on random, especially the cheaper ones. All right, so let's allocate our memory for it. So unsigned char tile buffer. So we got that, and then we'll just all right. So we've got our buffer size. We've allocated it and set it to 0, and then what we're going to do is we're going to change this to write out our tile buffer, and then from here we're just going to let's see how I'm thinking I just want to be really kind of simple about how we're going to handle this. So y is less than image height plus y plus, come on, plus equals 8. So that is our our vertical movement on the image, and then same thing with this. We're going to add our 8 to it. And then, let's see. So, like I said, our tile buffer can even be kind of lazy about how we do this, where we say temp is equal to image indexed x plus y times image width, right? So that gives us our position, and we're going to do that 8 times. And I know I gotta fix this, just give me a second. So that's gonna write our write it, and then let's do this. I was thinking it'd be really annoying and do the pointer increment within the assignment statement, but I feel like I always mess those up, and it's just better not to do that. It's just cleaner. Doesn't really take anything away from the code. Still got to do the assignment first. So let's just look at this for a second. You know what we could do? Well, I don't like doing that. I was going to say we could increment the index of x, but I don't like doing that. I prefer to keep the indexes modified by the for loop. The other thing I realize is that this is kind of not going to work because I'm not thinking about this the right way. So we're getting the x stride of 8, and then what do we need to do? Then we need to go to the next. This is only part of what we need. So let's do this a little bit differently. We need the y offset as well. Yuck, this is getting ugly. So how can we do this in a little bit less of an ugly fashion here? Because we're just going to have a bunch of nested loops, essentially. Oh, you know what? We can be a little bit smarter about how we do this. So let's memcopy to temp image indexed. So that's that, and then what we can do. 4, 5, 6, 7, 8. So that's our 8, and then so we're going to increment to the next line. So okay, so we're copying our 8 values, and then we're going to the next line. So that gives us all our tiles, or sorry, all the rows of the tile. So now we've got all the rows of our tile for the first tile. And then we're going to go to the next tile, right? So if I'm thinking about this right and not confusing myself, we get this first tile, and then we're going to go and do this for the next tile, and then we're going to go next tile. And the only problem we have is that the temp value is not going to get reset properly. So let's do it this way. This location should be plus y times image width plus x, right? That's going to give us our starting point for the tile, and then we do our copy of the tile, and then we're done. I think that's right. And so if we go to this and just make sure that that's saved, what we should see is that now we should get this tile, then that tile, then that tile, then that tile, which means that when we go to view it, it's going to look wrong, but that's okay. Let's try this out. So we're doing PNG to Sprite, project shooter assets, PNG, new ship.png, and then we want the metadata for it. I think that's what I called it, right? No, I just called it player. All right, so hopefully this won't crash. Okay, it didn't crash. That's good. So let's see. Just save that off there. And then I want I want to see what that looks like. Did it not like that for some reason? I thought. Oh, why is this in release mode? There we go. Okay. That actually looks right. Why? That shouldn't look right. Unless I didn't do it right, which is entirely possible. Okay. So let's take a look at this now. Okay. So that's, I'm not surprised that it doesn't look right, but I am surprised that it's not showing anything. Let's take a look at this in, maybe the palette is wrong and that's why it looks like it's wrong, or it could just be, no. Oh. Nope. Stupid. That was wrong. Okay. Create sprite. I freed the memory. I freed the memory. No, I didn't free the memory. Why is the... I didn't free the memory, which is fine, because we're just calling this and exiting. I mean, in theory, we want to do, right, free tile buffer. But what happened? Let's take a look. Oh, I got to change the arguments again. What's tile buffer have in it? All right, it has real data. So right, tile buffer, size of image W, H, and then free, and then the bounding boxes. Okay, that all looks okay. what is this? Why does it have all this uninitialized data in it? Oh, is that... You know what that might be? That might be... That's that reserved area. Am I not initializing... I wonder if I'm not initializing the structure that it's using. Well, that's interesting. I'm surprised that it is not initializing that thing. So let's just do memset sprite 0 size of sprite. It should all just be 0. I'm not sure why. Let's take a look at that. Oh, it's not called new sprite here. Initial data. Got a bunch of nothing in it. What did it think the meta target meta player.json? Did it get messed up because it's got these additional fields in it? I wonder. It's not particularly resilient if it is the case, but let's see. Is it not like the comments? I don't know. Let's try again. Yeah. Here we go. That's actually got some data in it now. It's weird. Unless I was just missing it, but... Alright, so new sprite. Now has that data there. The reserved area is zeros. Oh. Interesting. It's because I'm nulling out these... No. What is... Oh, I see. It's the rest of the string name there. Why? Oh, okay. All right. it's not what I thought it was. I thought it was the reserve data, but it turns out it's the, because we're running in debug mode, it's storing the FE stuff in there past the null termination. That's part of what Microsoft does with uninitialized memory. It's to help you identify problems where you're operating on uninitialized memory in your program. I thought it was the sprite structure not being initialized properly. Anyway, sorry for that detour. I was just thinking it was the wrong thing. All right, so here's our tile buffer. And it basically has 0B in everything. Now, that would imply that when we went to load the image and convert it to index, that it must have had a problem where it ran out of sprites and palette colors, and then it kind of reduced everything to nothing. All right, so how do we want to handle this? Because this is the other problem that we're facing with this process, right? Because we're introducing the possibility that a sprite image that we're importing, or a sprite sheet that we're importing, has more than the 4 colors allowed per palette. We need to be able to import something that has more than 4 colors and not let it get reduced like this. So let's go back for a second here. When we import the image, this is just, okay, so that's just literally loading the image, and then we are converting it to indexed. So this is the part where we're converting it to the NES color palette using our YUV process that we wrote the other day. All right, so current image, I think it's indexed. If we look at that in memory, we should see, we see some other colors besides that 0B. So now when we go to load image palette, what we're going to find, I think, is exactly what I'm saying, is that we're going to exceed the maximum colors. Yep, so we have 5 colors. Let's see, how do we want to handle this? I think what I want to do, sort of keeping along the vein of things being relatively simple, I think I want to make it so that a sprite can only have in it 4 palettes. Since that's the maximum that the sprite itself can, or that the system itself can ever load. So I want to make it so that we have a maximum of the 4 available. And then make this 16. Yeah, actually this is better. Make it 16. And then we check if we've exceeded that. And hopefully, I don't know if I have too many things that are doing just a check on 4 colors. I think I used that constant. So let's see if we end up with something that looks reasonable, even though we know it will not translate to the NES now. Well, you know what? Let's just go for broken. Get it written out. I just want to do one quick check here. Come on. I only see the color 2. So the question is, did that actually... All right, so interesting. So the image is okay. It's my tile buffer. Unsurprisingly, my tile buffer copy looks to have been done improperly. Let's see if that's true or not. I don't know why it doesn't want to capitalize. Yeah, it doesn't look right, but let's give it a shot and see. I'm pretty sure that that's going to be, it's going to just be a solid color, and then we have to figure out what I messed up. In case you haven't noticed, this is a recurring thing, is that I like to make a single change, see what I broke, and fix it, because otherwise too many things change, and then it's really hard to figure out what I messed up. And because this is all stuff that I'm kind of learning as I'm going, it is easy for me to break things. All right, so we have our y times, we're going from the height, from 0 to height, and 0 to width, and x is being incremented by 8, so we start with 0, 0, and the tile buffer temp is located at the beginning of tile buffer, and we will oh, wait a minute. This is the problem. We just want to increment by 8 each time, because the whole point of what we're doing here is to store a single tile at a time. So we store 8, and then we move to the next part, and we store another 8, and we move to the next part. And then once we've done that, we're done with the tile. And we go to the next tile, and we do the same thing again. And the problem, let's see. This is wrong, because we want to go based on tile count. So what we want to do is we want to say x plus y times image width divided by 8. And then times that by 64. 16, 32, 64. Multiply that by 64, because we want to go, once we get the tile that we're on, we want to move 64 bytes. So if we were to do this, we get, so this is our buffer, and we're writing 64 bytes, and then 64 bytes, and then 64 bytes. And if we look at the image, what we're doing is we're traversing it this way. And so we go here, and then we go here, and we go here, and we go here. And so, yeah, that looks, so y times image, oh, you know what? No, this is that going to work right? If we have 0, if we have 8, then 1 plus 0 times 64, that's the row, almost. this y almost got the math right here. It should be whatever the y value is divided by trying to think about this because we're moving in increments of 8, so we just want to multiply by image width divided by 8. So what we're doing is we're taking the y and we're multiplying by the number of tiles in the width, and then plus x, whatever that is, divided by 8. That's the tile that it's on. And then all of that times 64. Which is shift left 6. And that should give us what we want, I think. Come on. I don't know if that's right or not. It doesn't look right. Nope. All right. So, what am I? I'm just having a brain fart here with the math, right? So, whatever the width is, we want to divide it by 8 to get the number of tiles. So, in this case, the width is 16, so we want to divide by 8, so we get 2. So, oh, this is the problem. The y value is in the wrong. This also has to be divided by 8. The reason that has to be divided by 8 is because we want to know which row we're in of the 8 by 8 tiles. This seems really dumb. Also, I just realized that I'm stupid. Hold on a second. Like, how dumb am I? So the other problem is that it is not... It's copying... Wow, okay. I'm so focused on trying to be smart about this that I'm being really stupid. So it's not even dealing with this properly. This... Let's rename this. Okay. So this is image indexed plus x plus y times image width. Right, so this is going to give us our source memory location. That's our destination memory location. And the source needs to be incremented by the width of... So I was confusing myself by trying to combine sort of the two operations and getting the wrong thing. So we need to increment by the stride of the image, which is the width, in order to get to the next row to do this copy of 8. 8 values, which we weren't doing. The destination just gets incremented by 8 after every mem copy. Now, let's see. So the destination is the X. This is divided by 8 because we want to know what the position is relative to the tile, because we're adding 64 bytes for every tile that we've dealt with so far. This is also divided by 8 to get the tile, but then we are multiplying by the image width divided by 8 in order to get the number of tiles. You don't really need to recalculate that every time. We can maybe simplify this out, but so that's that. And then we want to multiply that all by 64 because each tile is 64 bytes. All right. And I forgot a parenthesis somewhere. I just have an extra one there. Was it running still? All right, so here's our argument for that. Let's take a look at this for a second here. It still looks wrong. Well, actually, it looks a little bit. It looks wrong. It looks like I may have gotten some of it. Let's step through this because I feel like I'm close. Just made a dumb mistake somewhere. All right, so at this point, this should just be 0, and that's 0, and that's we're gonna end up with destination is equal to tile buffer. 748, 748. The source is the X plus this. Or this should. I mean, that's technically, that should work because of the order operations. That's fine. So that's our source. So all right, so we get our first 8, and then destination gets incremented to the next 8 position, and the source gets incremented to the next row of pixels, and then we do our copy again. Oh. Damn it. All right, so that explains part of it. Okay. And then this grouping is, not that it affects the code, but I want to keep things together that belong together, so visually they make sense. This doesn't need to happen. Okay. Let's go back to this tile buffer. Okay, so now we're getting some more reasonable data popping into this. I know this is probably hard to see at the top there if you're on something with a small screen. So now the next location of memory we populate should be where the cursor is blinking, if I didn't mess that up. So destination and source are set. So destination, that would be 8. So give 1 plus 0 image width is 0, so this times that, and then 64. So okay, that seems right. Okay, good. So that wrote into that location like it was supposed to. All right, so that's looking better now. It looks like we're actually getting data that's supposed to be written correctly written. So let's take a look at that. Okay, so that's, we can see there is some of the data correct, but what is wrong? Let me think about this. So if this is a 16 by, is this a 16 by 16 or is this a 32 by 32? I thought it was 16 by 16, but oh yeah, it's 16 by 16 because this is an 8 by 8 grid. So, all right. What got messed up here? This is why I don't even think that this is the problem. Is it this? Image index plus x. Here's our x and our y times the image width. Well, I mean, that seems right. And then it's just incrementing by image width. That actually seems right, assuming that it's, just for the sake of my sanity, let's make sure that we're forcing that. I mean, it should be doing it that way because of the order of operations, but who the hell knows? Sometimes it's better not to assume. Or did you run? Okay. So let's see what it did. It looks the same. Okay. So now, I mean, what we should see is we should see this, then this. Well, no. Actually, maybe it is working and I'm not thinking about it right. So let's think about this for a second. So what it should be showing, so previously we were storing the image all contiguously row by row, and now we're storing this first tile and then this tile, then this tile, then this tile. So what we would actually see is this stretched out. This might be working. It might be working, but because of the way that we are rendering it, it's not drawing properly. So let's fix that. Let's load the sprite. And so the question is, do I want to make the drawing routine handle that properly or the loading routine? Because right now the drawing routine is just taking the data raw and drawing it out. And that would mean that the drawing routine would have to understand that it's in a tile-based format instead of just a linear buffer, which I'm okay with, but at the same point, might be better for it to, okay, I think I want the drawing routine itself, the drawing code not to change. I think I want to just change this part where it draws it onto the image to understand how to do this properly. So what I need to do is I need to the nice thing about this is that this should be relatively simple. So what we're doing is we're going to say from I is less than total bytes, right? That doesn't change. We're going to do I equals plus equals 64, right? Because each one is 64 bytes. And the only difference is instead of just linearly copying this, we want to do it as a tile. So that's getting the RGB value, and that's getting the indexed value. That's why I don't like working in this mode. It's just less intuitive for code, but we're going to need it that way. Trying to think what's the easiest way to do this. I mean, we're just going to reverse the process essentially. So now what we can do is we can say, we still need to handle this one by one because we've got to convert, so you'll have to forgive me for all these nested loops, but actually, you know what we could do? We could pre-convert the RGB value into another buffer and then use that. You know what? Let's not do that right now. So what we need to do is actually that doesn't even really help us. So that's our pixel location in that, and that is, and this is just a straight up I think that's all we need to do. Because this is just sort of a one-for-one placement here. Since we need to do these conversions and whatnot. So what did I mess up? This. Okay. assume that I did not mess up the sprite width and height here. They should just be 16. It should just be 16 by 16. So that would be 16, and that would be 16. So that should be okay. Oh, no, I'm just being dumb. Because we're not doing it in chunks, we're just doing individual pixels. We just iterate through it this way. Let's see. Except I just recreated the same problem. Oh! What's going on with me today? Okay. I just basically recreated the same problem in a different way. That's what the problem is. Let me think about this instead of just writing code that's dumb and not working. These are 8x8 tiles. These are not. Go back to this for a second. And what I want to do you know what? Instead of making this harder for myself and not modifying the index, I don't want to do that though. I don't like doing that. It's just going to make it harder though. All right. Screw it. So what I need to do is I need to say, all right, the same thing as before. Say tile position is equal to x divided by 8 plus y divided by 8 times the image, the sprite width divided by 8. That gives us the position into the sprite that we are working, the position into the linear, and then multiply by 64. That gives us the position into the image that we are currently working in. Okay. And then just increment this. And then this actually I think we can get away with. Not changing. So let's think about this. For consistency. So let's see. So the tile position, that gives us 8. Oh, but that's only 8 pixels. I don't really want to do that many times. Let's just do this. What do we need to do? We need to say tile position. No, let's do this. Int is I equals tile position. I is less than tile position plus 64. Plus I. Get rid of that semicolon. Make this I, and then what we're going to end up with is we're going to end up with we're incrementing X, we're incrementing I, except this is wrong too. Damn it, what the hell am I doing wrong here? Why am I having such a hard time visualizing this? I think I'm doing it, trying to think about it backwards. Do this. So we know that that's going to iterate over the sprite properly. Oh, I don't want to get rid of that because I need this code here. The problem being that I've got to copy the 64 bytes that are in a different layout to the sprite image data. So my source is this, and this is same as before. Right? This hasn't changed. This is our layout of the memory, where we're finding the number of it's just character not unsigned. Okay, finding the number of, now what? Finding the number of tiles that we're in and multiplying by 64, and that's going to give us, right? So that's that. And then we want to do 8 memory copies. But we can't just do 8 memory copies because the values that we're getting are not, they need to be themselves converted. And so what we need to do is we need to say I know this is wrong. Just give me a second. Actually, no, this is fine. So now that only touches the first pixel properly, right? Because we've got the first pixel of that. So then what we need to do is we need an offset that affects all of these, except that the offset really is only applicable to this source, so that's no good. And what we really want to do is we want to have all right. Right, so these are our two destinations, and we want this to be the RGB destination, and then this is our indexed destination. Except this is wrong. What is this? This is a t-pixel pointer. And this is an unsigned char. And then this needs to be this and that. Oops, I don't need that twice. And then the problem is that we want to do this. We want to do this 8 times and then increment to the next row. Right? So what we want to do is we want to say is there a better way? There's got to be a better way to do this. I feel like I'm just overlooking. I'm so focused in on how the destination memory is laid out. If we just traverse this directly, we can just convert this to the memory layout of the other one. We can just do something like this is x plus y times sprite width, right? Can we just convert this over? Let's see, based on the X and Y, we can figure out which tile we're in, right? We can say, okay, we're in this one or this one, and then we should be able to look into which one that of those we're in, right? So we should be able to say, let's see, unsigned nth tile offset is equal to this whole mess of crap. Right, so that's our tile offset, and then we need to know what our offset is within that. So then it is x mod 8 and y mod 8 plus y mod 8 times 8. Is that right? So if we are yeah, that, let's think about that. So if we are in a situation where we're in the second tile, x would be 8, y would be 0, and we would get, let's see, x mod 8 is 0, and then y mod 8 is 0, and there is no offset there, but we would also have 8, so 1 times 0 times 64. That looks right. So that would be the offset there. So then we can just say, take this tile offset and use that to do this. And of course, I'm modifying the wrong thing at this point. Man, all right, let me go back to this. Gonna look at what this originally looked like. Hey Eugene, yeah, daylight stream, although I'm not sure that I'm any more awake than I usually am, so having some interesting challenges today, sorting through some things. Let's see. Let's take a look at what I modified, because I broke this draw sprite. So it's image pix. So this should be pix x plus y times sprite width. And this should be indexed x plus y times sprite width. And then this should just be, what is that? That's sprite palette, sprite image. Okay, so there's that, and then image index, sprite image. So this is just sprite image tile. This is all garbage. Let's see if this draws. All right, so it gets the first one right. So that's progress. Hey, okay. So what's wrong with the next tile? Let's see. So if we are... Let's see, so we've got this x value that it's translating over. Let's take a look at this. Okay. So our offset at this present moment would be 0. This is all correct, and then what we should see is that the offset should jump after the first 8 pixels. Yep, because now we are into the next tile. So, okay, so now in this case, x is mod 8, so we'd get 0 plus y is 0, and then that's, okay, so that's fine. So we should get 64, 65, yeah. So that's weird. So then why, is it just, is that wrong? Is it the stored off data is wrong maybe? Because I'm not sure how this is right for just this part, but not the next part. Because after y hits 8, let's see, so y would be 8 divided by 8, that would be 1 times the width is 16 plus, let's say 0, and this would be 1 times 8. So that all looks good. This would be 16 times 16, 1, yeah, 16. Oh, wait a minute. That width has to be divided by 8 as well. I don't think this is going to fix the problem, but it's wrong. No. What's the problem? I guess I didn't need that. Okay. Is it just wrong in the way it stores it now? Is it not? Is it not handling the y value correctly here? One, two, three. So this is writing out each row of 8. What I want to do is I want to see what this looks like. Oh, it's not going to call that because I am not exporting the data again. I should fix that. So I saw the source code for the SimCity prototype has been released along with the ROM. Would it be a useful thing for homebrewers to study? Do you know, is it assembly, Eugene? I assume it is. So that's 8. Tile buffer. Next plus x plus image width. Let's take a look here. I just want to look at I want to compare what I'm seeing in source versus the destination. Because what I should see, let's see, I believe so, but supposedly they copied the code from the PC version. Should read up on it more. I mean, the thing is, if you're looking at the assembly, I mean, it might be interesting, but it's also going to take a huge amount of time to understand what's going on. I mean, sometimes it's hard for me to remember and understand what I'm doing, and I wrote the code. For something that you didn't write, it can be really tough. I mean, if you let me see if I can find that real quick. SMB commented source code. There is so comprehensive Super Mario Brothers disassembly. So somebody took the time to take all the source code for Super Mario Brothers and write an extremely complete version of the code from the raw assembly data. And my understanding was that this took months, I think, to do. But basically, it is looking at raw assembly is insane. If you are just getting started, only because there's so much about what you're doing in your code that's specific to your code that it's hard. So high level languages, you have the benefit of, like, you have things like, variable names to help you, and comments and stuff like that. With these assembly dumps, you have literally just the instructions and address offsets for your jumps. And so if you're really skilled at 6502, and this is not to say that I am, so I'm not saying that I can do this. I'm just saying that if someone is interested in it and they're like super into and skilled with 6502, then they could look at the code and actually start to make sense of it. But even then, you're still spending a ton of time looking at what the code is doing to understand what memory address is used for what. So, for example, cold boot. So let's see, what is that? Cold boot is, it's a label. Let's see. Let's take a look at something that it will. So warm boot validation. So warm boot validation is a variable that's being used for something. It's at this address. So all you'd see in the code is 07FF. And in the couple of places where it's used, you would need to kind of piece together what that address is actually used for before you even understand why it's why it's operating on that memory address. Like, there's this whole, it's not just looking at code and understanding the instructions. It's like you're literally given a blank slate of memory and a bunch of operations that operate on that memory, with nothing to clue you into why. And there are going to be things that are just common, right? Like, so you're going to start, maybe the easiest thing is you say, okay, well, I'm interested in seeing, how they handle input, right? And so you might do something like, do a search for wherever in the code you see references to address 4016. Now, in this case, this guy's created some defines to it. So, you'd say, okay, this is where they're handling input. So they're loading the 1 and storing it into that, and then they're doing the shift and transfer and store. Like, there are going to be key clues, right, that help you figure out what parts of the code are doing certain things. And then you'd also be able to find things like the interrupt vectors, right? You'd be able to find where those live, because there's a specific location in the ROM where it has to identify where those routines live. But like, you get stuff like this where this is just raw data. I mean, they're just numbers, right? And you've got to look at the code and piece together how all of this fits together. It's pretty insane. It's pretty insane, and it's a lot more work than looking at higher level languages and trying to understand what's going on. So it might be interesting. It might be interesting to see, how much code there is and if they're doing any sort of odd tricks in there, but to actually piece together how it works sounds like, months of study. Yeah, no problem. I mean, I'm sure it's interesting. The fact that the game is actually mostly complete, is really pretty amazing. I know that when the prototype was initially found, people were concerned about, whether it would ever be released to the community, and what the state of the game was, and people were playing it and seeing that it was working pretty well. But it's really cool that it was not only released, but now people are interested enough in it that they're kind of piecing together how it functions, and how it compares to other releases. Really, really cool historic find. All right, so let's see here. What am I doing wrong? So what I should be seeing here is that I'm copying. I mean, this looks right. Y is 8. If I'm thinking about this, so if it's a 16 by 16, then my destination should be minus tile buffer. It should just be, yeah, it's 2 tiles. It's 64. So that's good. And then my all I did there was I said, okay, this pointer should be 2 tiles in from the beginning of this buffer that we created, and it is, because each tile is 64 bytes. And then let's see, so then my source should be now the source, should that be the same way? Yeah, it should be, because although the data is organized differently, where it's organized purely in a row by row fashion, 16 by 8 we would have traversed. So if we did 16, we do real quick 16 by 8, that's 128. So that's the fact that they're the same exact offset is good. Let's see, so then we're copying, I guess that's copying correctly. The offset by 8 is right, and the offset by width is right, and then we move on to the next X position. I mean, that seems, let's compare this to, let's just go look at the actual image for a second here again. What I should be seeing at this point is 1, 2, 3, 4 of the same color, then a different one. I am, and then the same color again, and then a different one, and then another different one. And then I should be seeing 2, well, let me think about this. Yeah, so then the next tile should be, did we copy that already? We didn't copy that already. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, and then we got the next row. I mean, that doesn't look wrong. We get 2 of those, and then a gray one, and then the background, and then another gray one, and then a light gray one, and then 2 of the magenta. So that looks okay. It looks like just the load then may be what is incorrect. Because by all accounts, the data is looking good to me. So is my offset here by Y incorrect? Because we're getting to the point where, let's see. So Y divided by 8. We'd have 8, so that would give us 1 times the width, which is 2, right? Because it's 16, so that would give us 2. So that would give us 2 tiles plus 0 tiles. Is it just my grouping here? No. What about this? What is this? That's all times 64. Let me just see something here for a second. Wasn't expecting this to take so long. So this is just giving me the first color and using it for everything. So for the first 2 it's fine, and then for the next 2 it's not. So what am I? Tile offset. What are you doing? What's the problem? Oh, it's still open. Curious to see what it prints out here. That's pretty much what I expected it to do. So nothing wrong with that. And then if we, whoa, doing some sort of multi-edit, which I didn't want. Hey, Visual Studio, stop it. I don't know what you're doing, but I don't like it. Stop trying to be clever and help me. Just do what I tell you. Okay. So now those coordinates look correct. So that's that, and that gives me y times sprite with, oh, is this right? Yeah, that is right. Because that width is still always 2. So that's offset by 64 bytes. That's bizarre. That is strange. What's even stranger is that they're a repeat of the same 2 tiles. If you look at the hex code data, let's take a look here for a second. The image data will be right after, we'll see some null values, and then we should see, so this is our image data, and so it's 64 times 4, so that's 256 bytes. So that is our image data. Which means that, let's get 64 bytes here. This is the last tile. I want to paste this into here because I want to compare it. Oops. I just want to see. They should be different. Okay, but they're not. Or at least not that I can see. Okay, so it is actually writing it wrong. Well, that stinks. Is it my Y offset logic that's wrong here for the source? The Y times the image width plus the X. Why does that only work? If Y is 0, if Y is 8, we get 8 times the width, which is 128, plus X, which would be 0. This is Y divided by 8 to get the index times the size of, yeah, so that's the number of tiles, and that's X. Should, oh, you know what? I wonder if that was the problem. I think I had the, because I was missing those parentheses, it was applying the shift too early. Let's see. Let's, before we run this, let's reload this file. It doesn't look like it actually changed anything. That didn't change anything. Tile buffer. X coordinate plus the Y coordinate shifted over, plus that whole thing by 64. Okay, well, that is the wrong thing that I wanted to do. See, I knew this was going to be a pain. I just didn't realize it was going to be this much of a pain. Because I always make some stupid mistake with the way that we are when mapping over like this. And you'd think by now I'd have figured it out. I mean, the thing is, though, that this all looks right? The index into the source image is the image indexed data. Is the image index data wrong somehow? I mean, it shouldn't be. X plus Y times image width. Oh, wait. I don't want to do that there, but so that's the source. If we go back to the memory here for a second, if we take image indexed and compare it, yeah, it's different. It is actually offset. It's really strange. Because if I look at the image, let's see, 22222023, 22222023, 1, and then it'd be 1132, 0, 2, 2. Yeah, that's okay. So this is all this image data as expected. So that's the first row, and then that's the second row of 2, 2, 0, 2, 0, 3, 1, 1. So it's putting that into the buffer. And that would be it. It should be done. If we look at the last bit of it, I mean, that all looks right. I am confused as to why this is not showing what I expected to show. Did this not reopen the file properly, and it's just caching it, and so the file is correct now? .256, so that's our image data. And that's 64 bytes there, yeah. And then did Fred not copy the buffer like I wanted it to? Okay, so they're different. What the hell, man? So they are different. Did I just not copy it when I was... Okay, so this is definitely now just a reading problem, because it is there, so what's the problem? What's up with my offsets? Why is the Y value not getting translated into my tile offsets? Okay. So we've got the width going there, tile offset. And as soon as we hit the 8th one, we jump to 64. And when we're done with this row, what we should see is that the tile offset again starts at, okay, so that starts at 8. That's correct. So now let's think about this. So the next time around, we should be starting at 128 for the tile offset. Okay, and why? Oh, well, no, sorry, because Y isn't, yeah. Y is not jumping by 8, is going one at a time. So 3, 2, 2, 3, Can I speed this up somehow? 4, 5, 6, 7. So now we're at 8. So tile offset. Why did that become 0? X is 0. Y divide. What did I do wrong? X. So X. Yeah. Okay. So X is 0. X plus. So it's 0 plus Y divided by 8 is 1 times. Sprite width divided by 8 is 2 times 1. Yeah. And then multiply by 64. Right? That should give us a reasonable value here. Except it doesn't. Is it because X is 0? And I forgot a parentheses. Okay, so this was shifting 3 plus all this other garbage. This is why I don't like to rely on order of operations, because I just like to be explicit about it. And there we go. Well, that took a lot longer than expected. Collision points. I don't know why that crashed, but I'll worry about that later. All right, so this is actually loading now with the right colors. So now, as long as we're not exceeding 16 total colors, this will work. Now, there's obviously a lot more to do still, because we can't load that as is. But I have exhausted myself on my own on dealing with this nonsense, and I'm ready to call it. Well, how long have we been streaming? 2 hours. I think 2 hours is like the most that I ever want to do. I wish I could get more accomplished in 2 hours, but unfortunately, when you're dealing with something like this, and like I said, I typically have this problem where when I'm mapping from one representation to another, I make a dumb mistake like that, and then, you know, in this case, the math was technically, I had the right idea, but I had the operation messed up because of the parentheses. Anyway, excuses aside, 2 hours is the most I really want to do. These are long enough as it is for people to sit through, so what we'll do on the next one is we will make the rest of this JavaScript stuff actually work, so that here we can move this back in. Actually, I'm curious to see if it cares about this stuff being in here, or if that was some other. Let's see. I promise I won't go much longer. I just want to let's see if it cares about that. It shouldn't. It should work. Okay, and then it shouldn't care about the stuff that it doesn't look for. Yeah, that seemed to have worked. Okay, so yeah, so for the next time, what we need to do is we need to have it actually look at this sprite position thing to say, okay, I'm looking at this PNG, and I know that at 4.0, here's an 8x8 that I care about, and then there's this 8x8, and then there's this 8x8, and that will allow us to be a little bit smarter about how we're extracting these, and then also be able to define which palettes are used so that we can have a sprite that has multiple palettes, and start dealing with that properly, so we can start swapping palettes in and out for the enemies. since we have all these cool things that Jordan has put together, and hopefully will continue to put together. It'll be awesome to get some of these enemies in there and actually be able to use them. Anyway, thank you for watching. Should it be centered in that square? Well, the problem with it being centered is that because of it being 8 by 8 and an even number of pixels, you can't actually properly center it because here, let me go to a Sprite. Unless you make the sprite actually have the same. If you have what you can do is you could double the thickness of the center, but because this is an even number, there is no row of pixels here in the center, so you can't actually center it. It has to be offset by 1, which is one of those sort of annoying things that you just deal with, and which is why the collision points will be, you know, set according to the sprite anyway. So so we need to be able to define how these are all split up, and yeah. So yeah, thanks for watching. Apologize that this was a sort of daytime stream, but since I'm off from work and we had some stuff going on anyway during the day where I was going to kind of just be at home. It made it easier for me to do, and hopefully for some people to catch that normally can't. Like Eugene, you're usually busy at night and or dealing with getting a child to sleep, as are many others. But yeah, hopefully this was good and people got to watch it, and of course I'll post the recording on YouTube. If you have any questions, you can reach me on Twitter at Clairvis. You can add a comment to the recording on YouTube. You can find me on Nintendo Age at Zelius, as Zelius, and Clairvis is my Discord name also. I've got my Gmail email, which some people have used. And I will have some details coming up soon about the pre-order to get a handle on the source code, as I mentioned at the beginning. So keep an eye out for that. Just kind of dealing with the logistics of actually selling something, and what that means, and putting together some of the naming and stuff that we want for the that I want for the project. And yeah, like I said, I'll be at MagFest next week, so hopefully I'll see some of you there. And I'm going to wrap up this because I am just rambling. So thanks again, have a great day, and talk to you later.